Hello, I'm Todd Strother, and I'm a scientist at Thermo Scientific in Madison, Wisconsin. And I'd like to talk to you today about our Nicolet iS50 FTIR spectrometer. Today we'll be looking at some polymer analysis using the spectrometer. And our goals today are to collect mid-infrared spectrum using the built-in ATR device, and then also to collect far-infrared spectra using the same device. People who would use this particular device would be researchers or developers who might want to deconstruct material for their particular products, or regulatory labs who are searching for restricted materials like heavy metals in different polymers. So let me go ahead and introduce the instrument to you. First of all, it is an FTIR spectrometer, but we have several components that can be attached to the spectrometer to increase its use. For example, we have a near-infrared module that includes an integrating sphere and a SABIR probe. We do have a Raman accessory in the accessory compartment. And we also have attached to it a GC instrument to do further analysis. Today, though, we'll be looking specifically at the ATR, the built-in ATR device. So first of all, let me collect some mid-infrared data using the ATR. And all this is as easy as pushing the blue button to collect the spectra. So I'll go ahead and push the blue button. That will allow the accessory to collect a background. On the screen, we'll see background show up. And then once the background is collected, we'll be able to analyze our sample. All I need to do is to put the sample on the ATR, pull down the pressure tower until it clicks, and push the button again. The sample is now being collected, and we'll wind up with a spectrum on the screen very shortly. So here on the screen, we have a typical mid-infrared spectrum. This is the spectrum from our sample, which happened to be a biodegradable or compostable fork. And we can see we have several peaks that we might look at, but we notice over in this region, in the far infrared region, we don't have any data. So what I'll do is change some of the parameters to collect the far infrared portion of the spectrometer. Once I set up those parameters, the beam splitter changer in the instrument will change the beam splitter to where it's allowed to collect the far infrared spectra. Meanwhile, while that's happening, I can look at the spectra and I can do an analysis, help determine what it is. I just go to Analyze, drop down to the Search button, and immediately the results from our search show up. And as you can see, according to the library, the sample is polypropylene that has 20% talcum. This is something we might expect to see with a biodegradable or compostable fork. And with those few seconds, now the instrument is set up to do far infrared analysis. So I'll go do that now. So with the iS50 set up to do far infrared analysis, all I have to do is push the button again to where it will collect background of the far infrared. And once the background is collected, then we can just put the sample again on the ATR and collect the spectrum. Put the sample on, turn the pressure tower down till it clicks, and then push the button to collect the data. You'll see in just a few seconds, we'll wind up with spectra in the far infrared region. And here we see once again the mid-infrared spectrum, but what we've done is collected the far infrared to fill in the areas that the mid-infrared spectrum hasn't shown. And there we see from the far infrared spectrum, the green spectrum I show here, we have extra peaks that you would not be able to see if you just did mid-infrared. Let me remove the mid-infrared so you can see the far infrared spectrum a little easier. And here you see the entire spectrum of the far infrared region down to about 150 wave numbers. And that's essentially it. So the goals for today were to collect mid-infrared spectra using the iS50 ATR, as well as collect far infrared spectrum using the same accessory. Thank you.